Today I am going to discuss the topic inverse function. This topic is by RBA Educational Academy. Here you will see the concept in a novel way. So I request you to watch the video from beginning till end. Now see here students, what do you mean by inverse function? The inverse of a function is it reverse, that is it undoes the function effect. How it undoes, I will show you. The inverse of the function f at x is written as f inverse at x. Suppose take the example f at x is x plus 2. In one way it can be represented like this, or here you see f such that function f such that x is mapped onto x plus 2. Suppose here I will take one example. Here I will draw domain and codomain. So here I will take the numbers in domain 1, 2, 3, okay, -1, -2, and f at x is a function is x plus 2. So f at x is x plus 2. So in place of x, if I write f at 1, 1 plus 2, that is nothing but 3. So 1 is mapped to 3. If I take 2, f at 2 is 2 plus 2 is 4. So 2 is mapped to 4. If I take 3, 3 plus 2 is 5. And if I take -1, now here f at x, what I had written x plus 2. So we took the numbers 1, 2, 3, and f at x is x plus 2. 1 is mapped to 1, 1 is mapped. If I write 1, 1 is mapped attached to 3. If I take 3, 2 plus 2, I have written 4. 3 plus 2, 5. If I extend the number -1 and -2 here, -1, -1 plus 2, 2 minus 1 is 2 minus 1 is 1, okay, with plus sign, because we take the sign of a bigger number always. So sorry for the disturbance boys. 1, 2, 3, -1, -2. So 2 plus 1, 3, 2 plus 2, 4, 3 plus 2, 5. Then here I want to show -1 plus 2, we get 1. If I write -2 plus 2, it is 0. So -1 is attached to 1 and 2 is attached to 0. So this was the function f at x. So these variable we call it as x, 1, 2, 3. We replace x one time by 1, one time by 2, then 3, -1, -2. When we write 1, 1 plus 2, we get 3. So 1 is attached to 3. 2 plus 2 is 4. So this number 3, 4, 5, 1, 0. These are the images. Image of 1 is 3. Image of 2 is 4. Image of 3 is 5. So these images we represent by letter y, or we call these images as f of x. It's same as f at x, but f at x is a function, it's not the same. F of x is a real number. Generally we say f of x this to function, and to image also we say f of x, but f of x is a real number and f at x is a function. Please remember. Now when we talk about the inverse function will be from codomain to domain. So when we talk about this, so here when we talk about the inverse function, okay, here the image of 1 is 3, so f inverse means 3 will be attached to 1. We see f inverse of y, we call this as x and this as y. So f inverse, I mean to say f inverse of y, that it will be nothing but it will be equal to x. This is the main thing which I want to say you. So boys, here I am going to show you how we will find f inverse of x. So f at x I will write here is equal to x plus 2. In place of f of x I will take y is equal to x plus 2, because x, its image is y, or you can say this as f of x. So here I replace f of x by y is equal to x plus 2, and plus 2 when we send this side it became minus 2. Either you can subtract 2 from both sides, y minus 2 is equal to x plus 2 minus 2 will get cancelled, you will get x, or transposition, we move shift plus 2 from right to left, so the plus sign changes to minus sign, y minus 2 is equal to x. Now when we define inverse function, f inverse of y will be x. So x is equal to y minus 2. X is the subject, so I write on left hand side. Now see here, f inverse of y, if I write here f inverse of y, that will be, when I substitute y in f inverse function I will get x. So in place of x I can write f inverse of y is equal to y minus 2, and if I replace y by x, f inverse of x is equal to x minus 2. In place of y I have written x. So f at x is a function, f at x is equal to x plus 2 is the given function, its inverse is f inverse at x is x minus 2. Now boys, here I want to say you one more thing. You can remember in another way also, that I am going to say you now. F at x, f of x, the image we call it as y. I can apply f inverse on both sides. F inverse of f of x is equal to f inverse of y. On right hand side I apply the inverse function, on left hand side also I apply the inverse function. F inverse means 1 over f of x is equal to f inverse of y. Now boys, see here f is in the numerator, f is in the denominator. Okay, you cannot cancel function, so it's better we say remove this both from the numerator and denominator. So you can say x is nothing but equal to f inverse of y. So in place of x you can substitute f inverse of y. X is nothing but f inverse of y, or you think that we substitute y in inverse function, f inverse of y, we get x. So in place of x, f inverse of y. The last step, y we replace by x, that is x minus 2. Now there is one more way. Okay, there is one more way to find the inverse of a function. So what is that way in which we find f to find the inverse of a function. How we can find the inverse of a function? Okay, the first step we write f at x is equal to x plus 2. So the first step is rewrite the function replacing f at x with y. So I will rewrite now. In place of f of x, I will write x y is equal to x plus 2. In place of f of x, this f of x, I replace f of x with y. See, I replaced it. Now the next step, interchange x and y. Here I mean to swap. In place of y, I will write x, and in place of x, I will write y. So now it will be x is equal to y plus 2. So I swapped. In place of y, I have written x. In place of x, I have written y. Now what is the third step? Rearrange the equation to make y the subject. Now I can subtract minus 2 from both sides or send plus 2 from right to left. So it becomes x minus 2 is equal to y. Okay, now you know it. I have shown you just now. Here x, here y. When we substitute y in inverse function, f inverse of y is nothing but x. So in place of y, last step, just write f inverse of x. F inverse of x, when you apply inverse function, you get x minus 2. So this was our second method. Now I will discuss with you the third method. Before graph I should have discussed, okay, but I will discuss. Nothing will happen here in the graph. I will discuss, then I will show you the graph. So step A, I will write a flow diagram for f. A flow diagram for f. How? X, I will say add 2 in flow diagram. So I get f at x is x plus 2. Now I will write a flow diagram for f inverse. Flow diagram for f inverse. Here it's very easy, simple. See here, I will start from right side. Okay, in flow diagram, just write the inverse. Add, I will write subtract. Inverse of addition, subtraction. So subtract 2. Though is we get x minus 2. So f at x is x plus 2, and f inverse at x is x minus 2. It's so simple. So now I will discuss the flow diagram with you. Just now I discussed flow diagram with you. Now I will show you the graph of f at x and f inverse at x. So 1, when I keep 1 plus 2, 3, because the function is f at x is x plus 2. This is the function. Now if I keep 2, I get 3. If I get 3, I get 4. If I write minus 1 plus 2 is 1. If I write minus 2 plus 2 is 0. 1 maps 2, 2 maps 3. If I write 2 maps 4, minus 1 maps 1, minus 2 maps 0. This is the function, okay, from domain to codomain. Now if I draw the graph, see the graph. So If I take 0, 0 plus 2, I will get 2. So 0 to 2, it will be here. If I write 1, 1 plus 2, it's 3. So 1 to 3 is here, my boy. If I take 2, 2 plus 2, 4. So 2 to 4, it's here. If I write minus 1 plus 2 is 1, minus 1, 2. So it's here. If I take minus 2 plus 2 is 0. So this represents f at x. Now let's see. This represent what? So let's see what it represent. It represent inverse function, that is f inverse, that is reverse of it, f inverse of x. So what happened? F inverse of x, just now I have done x minus 2. How it will be? If I write 0, I will get 0 minus 2, that is minus 2, 0 minus 2. Okay, and if you draw a line, this line is y is equal to x. You can see the symmetry. Okay, if I take 0, 0 to plus 2, if I in the inverse, if I write 0, 0 to minus 2 down. If I write 1, 1, 1, 1 plus 2, 3, 1 to 3. If I write 1 here, 1 minus 2, I get minus 1, boys. So here if I write 1, I get minus 1 here. You can see here minus 1. And if I write 2, 2 minus 2 will be 0. You see here. I will show you. F inverse at x is equal to x minus 2. If I write 2, 2 minus 2 is 0. So x2, when x is 2 in inverse function, if I write f inverse at 2, 2 minus 2, 0. So when x is 2, y is 0 here. If I write 3, 3 minus 2 is 1, 3 to 1 here. So you see here, when I substitute 2 here, 1 here, 1 plus 2, it's 3. Okay, when I substitute 1, I get 3. But when I substitute 1 here, I get minus 1. So see the symmetry, see the symmetry here, see the symmetry. Okay, if I write 2, 2 plus 2, 4, I get 4. If I write in this function f inverse 2, 2 minus 2, 0. So y is equal to x. This line gives the symmetry between f at x and f inverse at x. Now I will give you another example. If I take g at x is equal to 2x plus 4 divided by 3. Okay, I have to find the inverse function. So first step, in place of g of x, I write y is equal to 2x plus 4 by 3. Now there are two ways, either multiply by 3 on both sides, or you can multiply 3 with y, it's 3y is equal to 2x plus 4. The division changes to multiplication when we send from right to left. So 3 multiply with y, and see here we send plus 4 this side from right to left. So 3y minus 4 is equal to 2x. Next step, we want to make x as a subject. So I will write 2x on left hand side. 2x is equal to 3y minus 4. Then x divide by 2 on both the side, or send 2 on right hand side, 2 and 2 cancel. So x is equal to 3y minus 4 divided by 2. Now boys, see here, in place of x, I can write f inverse of y. F inverse of y is equal to 3y minus 4 by 2. Now in place of y, I replace x. Last step, f inverse of x is equal to 3x minus 4 divided by 2. Now boys, see here, there is easy way also. So to do this all, I will show you both the ways. I will show you the swapping way and I will show you the flow diagram way. So 2x plus 4 by 3. Now g of x is y. I think I have taken it's g. I should not write x. Okay, I should use g only. Okay, boys, see here, g at x is y. Y is equal to 2x plus 4 by 3. Okay, the first step. Then in place of g at x, I have written y. Then I will swap. The next step is swap. So in place of y, I will write x, and in place of x, I will write y. X is equal to 2y plus 4 by 3. I swap, boys. After swapping, now what I will do here, boys, either multiply by 3 on both sides or send the 3 to right hand side. The division changes to multiplication, so it becomes 3 multiplied with x. 3x is equal to 2y plus 4. Then I send 4 on the other side, that is 3x minus 4 is equal to 2y. Then what I will do, I will divide by 2 on both the side, boys, left hand side and right hand side. Rule, there is rule in maths. If you divide left hand side by a number, with same number you divide right hand side, so 2 and 2 get cancelled. So y I can replace by f inverse of x is equal to 3x minus 4 by 2. I got the same thing. So boys, now one more thing. The flow diagram. So the flow diagram for f. First I will write for f. So, or you can say g, whatever you take. Suppose g at x, what we have taken, g at x is 2x plus 4 by 3. So boys, so first I will write for the function for g, that is x, then multiply by 2. Here we write multiply by 2. So what we are doing, we are multiplying x by 2, so it becomes 2x. In this we add 4, boys, add 4. So now it becomes, boys, 2x plus 4. First we are taking x, you see here, 2x plus 4 by 3. So first what I have taken, I have taken x, then in this I multiply by 2, I multiply by 2, so it becomes 2x. In this I add 4, I added 4, so it becomes 2x plus 4, 2x plus 4. Now After addition, then what I am doing, boys? I divide by 3. So it becomes 2x plus 4 by 3. Now, boys, I will go the reverse way now. Okay, what I will do? I will go in reverse order. Same, but see here what I will do. I will take x from right hand side, take an x. So divide. Okay, first in place of divide, I will change it to multiply because the inverse of division is multiplication. So I will write multiply by 3. So it becomes 3x, boys. After that there is add is there. So you see this function add. So I will subtract now. Subtract 4. Subtract 4. So it become, boys, 3x minus 4. Okay. Now last step. Here multiply by 2. This is very important, boys. See, multiply by 2. So here I will write divide by 2 after subtraction 3x minus 4 by 2. So I got the inverse function 3x minus 4 by 2 in last. So I was writing x, so g at x was 2x plus 4 by 3 and g inverse at x, what we got by different ways, 3x minus 4 by 2. So here first step we have taken x, multiply by 2 first step, then add 4 and divide by 3. So remember, divide by 3. So we have taken x on right hand side, divide by 3, we change into multiply by 3, so we got 3x. Then add 4, we subtract 4, then multiply by 2, we divide by 2, so we got 3x minus 4 by 2. It's so simple, boys. I hope you understand. Thanks for watching the video. It's by RBA Educational Academy. Please like, share and subscribe. So till the time we meet again, please share the video.